Okay, here's warm-up 1.2. I'm going to sketch a graph of this function and include the critical points. So I've got an absolute value function here. So that's going to, it's important to know what an absolute value function will look like. It's going to be a v of some sort, okay? And this particular v is going to open upwards because I don't have a negative in front of the absolute value. If there were a negative there in front of the absolute value symbol, then it would be opening downwards. But this one's opening upwards. So first thing I want to do is find the vertex. And the vertex, I'm going to get the x-coordinate by taking everything inside of the absolute value function and setting it equal to 0. Okay? And then I'm going to solve that for x by adding 2 to both sides. So x is going to equal 2. All right, and then this is going to be the y. Whatever is added or subtracted to the end is going to be the y value of the vertex. So my vertex then is going to be the point 2, 1. Okay, so I'm going to plot 2, 1. So 2 to the right, 1 up. Here we go. Okay, and you could make an xy table to get some other points, but if you know what the parent graph of an absolute value function looks like, we can just plot these from that shape. Okay, so the parent graph from the vertex, this is our vertex here, you'd go up 1 to the right one and up 1 to the left one. And then you keep going up 1 to the right one, up 1 to the left one. Okay, now you can do a reflection where it would open down, but that's if you have a negative there. You could also change the width of the v, but then you'd have to have the x would have to be multiplied by something, or you'd have to have a coefficient out here. We don't have either of those things, so here is my graph. Okay, all right. Got another function here, and we're going to do some transformation. So first off, we're going to write function g, a new function that's a translation 2 units to the left. Okay, so g of x, I'm going to mess with f of x to get g of x. And if we're going 2 units to the left, then we're going to have to add or subtract. Well, when we go left or right, we add or subtract to the input. And you might think it would be x minus 2, but it's actually x plus 2. So if I did a minus 2, that would move you to the right 2, okay? All right, so I'm going to now figure out what f of x plus 2 is. So I'm changing the input of function f to x plus 2. The input is where the x goes, okay? So f of x plus 2, I'm going to take the x and replace it with the quantity x plus 2. Okay, I just took x plus 2, inserted it into function f where the x used to be. And now I'm going to simplify this. So all I can do here is combine the 2 and the negative 1 inside the absolute value into positive 1. And there's my new function. Okay. And you could test it out. If you found the vertex of this one, it would be 1, 3. This one would have a vertex of negative 1, 3, which would be 2 units to the left, right? Okay. All right, let's try h of x for going 3 units down. So I'm going to mess with this, with f of x, but I'm not going to add or subtract to the input. I'm going to add or subtract to the output. Since I'm going down, I'm going to be subtracting, and it says 3 units down. So notice, yeah, if you're adding or subtracting directly the x inside, that would move things left or right. This moves things up or down when you add or subtract to the end. So on this one, I'm not changing the input of function f. What I'm going to do is take all of f of x and substitute it in right there, okay? So f of x equals all of this. So I always use parentheses when I substitute. It helps out a lot. So that's what f of x equals, and then I'm going to be still subtracting 3 from it, right? So I took my function and subtracted 3. There's my function. Now I'm subtracting 3 from the end. And now I'm going to simplify this. So 3 and negative 3 combine to 0, to nothing. So then this is what h of x would look like. Okay? And here our vertex would be 1, 3. Here our vertex would be 1, 0, which would be 3 units lower. Okay? All right, and now let's do some reflections. So k of x, we're going to reflect over the x-axis. And that, to reflect over the x-axis, you're going to take the opposite of the whole function. Okay? As opposed to going over the y-axis, then we're going to take the opposite of the input. Okay, so I haven't finished that one yet, but I just want to show you the difference. This is going over the x-axis. This one's going over the y-axis. Okay, if you think about reflecting this point over the y-axis, it would be over here, which you'd change the x value, right? You take the opposite x value. So that's why when we're going over the y-axis, you change the input, you change the x's. And f of x is like our y, so when you go over the x-axis, your y would change signs. And that's why you take the opposite of the y or the f of x, okay? All right, so what I'm going to do here is substitute in what f of x equals, which is what I have circled up there. Okay, and I used parentheses here because there's a very common mistake, or a couple of common mistakes that get made. So I need to distribute the negative. It's not as simple as just putting a negative in front of the function, because I need to distribute into this whole thing, okay? And the other mistake that gets made is people distribute wrong. When I distribute this negative, I'm going to distribute one there and one there. But you can't distribute inside of absolute value bars. It doesn't work like that. It doesn't work like parentheses do. So all I can do is take the opposite of the absolute value part and take the opposite of the 3. And that puts me there, and that's as much as we can simplify that, okay? All right, so going over the y-axis, we're going to change the input. So I'm taking my original function, and I'm going to replace this input where the x is. I'm going to replace that with negative x. Okay, so I'm showing you where I did the substitution. Then there's very little to do because I don't have any like terms I can combine. And that's what m of x equals. You could actually, sometimes some books like you could change the sign of everything in the absolute value and it would be equivalent. So this would be equivalent to the absolute value of x plus 1 plus 3. So that would be an alternate correct answer. I don't see the point of doing that, but some of the books do that sometimes. Okay, that's it for this warm-up. See you next time.